Hello viewers, in this video we are going to learn about the execution of memory reference instructions in a basic computer. Before going to learn about the different operations which are performed by the memory reference instructions, let us have a look into its instruction cycle. In the first phase of its instruction cycle, the memory reference instruction is fetched from the memory and it is loaded into the instruction register. During this phase, the timing signals T0 and T1 are required. Okay, after this phase, the instruction need to be decoded. Okay, decoding of the instruction is very important because at the end of the decode phase only, the control unit will come to know what operation need to be performed. Based on that, it will initiate the control signals in order to perform micro operations by various units of the computer. Okay, this decode phase is performed when timing signal T2 is active. Okay, when decode phase is performed, this 12 to 14 bit of the instructions are decoded by the 3 by 8 decoder, and based on the input values, this decoder it will activate one out of 7 output lines which are designated with T0 to D6. Usually the memory reference instruction it takes the input values in the range 000 to 110, right? So based on its input values, one out of 7 output lines will be activated. Whereas coming to the 15th bit of the instruction, if it is equivalent to 0 during the decode phase, it will be received by the I flip-flop. So now I flip-flop value also will be 0. Okay, coming to the 0 to 11 bit of the instruction, it will be received by the address register during the decode phase. Okay, when 15th bit equal to 0, the address that is received by the address register, it will be a effective address of the operand. Okay, if 15th bit of the instruction equal to 1, then I flip flop value also will be 1. Then if 15th bit equal to 1, the address part of the instruction it contains the indirect address. Okay. So during the decode phase, the address register it will receive the indirect address of the operand. Okay. So in the next timing signal T3, the effective address of the operand need to be read from the memory, from the location that is pointed by the address register, and it has to be loaded into the address register. Now, at the end of the timing signal T3, the address register might be holding the effective address of the operand. And this phase is applicable only for the memory reference instruction which contains the indirect address in its address part of the instruction. Okay, so after this phase, the instruction execution shall start when timing signal T4 is active. Usually, for completing the execution of the memory reference instruction, it may take more than one clock cycle also. During that time, it depends on the number of clock cycle required. Number of timing signals need to be activated. Let us now discuss one of the important point of memory reference instructions. Memory reference instructions, for performing any of its operation, they refer to the memory unit either for taking one of the operand or else for storing the result. These instructions refers to the memory unit. That's why these instructions are classified under memory reference instructions. Okay, let us now discuss AND operation. The AND operation is performed when D0 output of the decoder is active. Okay, this AND logic operation is performed by taking accumulator value and the memory word that is stored into the memory unit whose address is pointed by the address register. Okay, and after performing the AND operation, the result is stored into the accumulator. Okay, here, since all these operations are performed by the ALU unit, okay, let us now discuss the inputs that are received by the ALU unit. Here, let us look at the ALU unit in the common bus system. This ALU unit, it receives its input from three registers only. One from the data register, another input is from the accumulator, and another one input from the input register. Okay, so these ALU units, it receives its inputs from 3 registers only, and it never receives any data from the memory unit directly to ALU unit. Okay, if any of the operand need to be received by the ALU unit, that is possible. First, it has to be transferred to the data register during the timing signal T4, and once it is loaded into the data register, in the next timing signal T5, the ALU unit can receive that operand. Okay, so this is one of the very important point you need to remember when you learn about the memory reference instruction. Okay, let us now apply this concept for performing AND operation. Okay, here as we just discussed during the timing signal T4, since one of the operand is taken from the memory unit, right? So that memory word is transferred to the data register. Okay, here the operand or memory word is taken from the memory unit from the location that is pointed by the address register, and it is transferred to the data register when timing signal T4 is active and selection signal values are triple one, and read signal of the memory is also active, and load signal of the data register is active. Okay, and at the end of the T4 timing signal, the operand which is read from the memory will be available in the data register. Okay, so during the timing signal T5, and logic operation can be performed between the content that is available in the accumulator and data register, and the result is stored into the accumulator. Okay, and end of the clock cycle, the sequence counter value need to be cleared in order to generate the timing signal from T0 for executing the next instruction in the sequence. Okay, whereas coming to the add operation, it need to be performed when D1 output of the decoder is active. Okay, here for performing addition operation also, one of the operand is taken from the memory unit and another operand is taken from the accumulator, and the result is the sum value is stored into the accumulator, and if any carry is generated, that is stored into the extended accumulator bit. Okay, here since one of the operand is taken from the memory unit, as we just discussed in the AND operation, during the timing signal T4, that operand need to be transferred to the data register, and during the timing signal T5, the sum operation can be performed by taking one of the operand from the accumulator and another operand from the data register, and the sum value is stored into the accumulator. And during the addition operation, if any carry is generated, that carry is stored into the extended accumulator bit, and at the end of the instruction execution, the sequence counter value also need to be cleared. Okay, whereas coming to the load memory word to accumulator, this operation is performed when D2 output of the decoder is active. Okay, so when this operation is performed, the memory word that is available in the memory unit in the location that is pointed by the address register, that has to be transferred to the accumulator. Okay, since there is no direct connection from the memory word to accumulator, during the timing signal T4, that memory word need to be transferred to the data register, and in the next timing signal T5, that content from the data register can be transferred to the accumulator. At the end of the instruction execution, the sequence counter value need to be cleared. Okay, coming to the next operation, store accumulator content into the memory unit. This operation is performed when D3 output of the decoder is active. Okay, let us check, is there any direct connection from accumulator to memory unit? Yes, there is a direct connection from accumulator to memory unit. So data transfer can happen in single clock cycle. Okay, so in order to achieve the data transfer from accumulator, the selection signal values need to be 100, because the decimal number that is specified along accumulator is 4. So the binary equivalent to the decimal number 4 is 100. Okay, and in order to receive the content, the write signal of the memory unit is also must be active. Okay, so in such case, when T4 is active and selection signal values are 100 and write signal of the memory unit is active, data transfer from accumulator to memory can be achieved. Coming to the next operation, branch unconditionally operation. It is performed when D4 output of the decoder is active. Branch unconditional operation is performed in order to transform the program control to the instruction whose address is specified by the effective address of the address register. Okay, this operation can be achieved by transferring the effective address that is stored into the address register to the program counter register. Okay, just I would like to remember one point about program counter is that program counter is always holding the address of the next instruction to be executed, right? So when branch unconditionally operation is executed, the program counter it will be pointing to the address that is transferred from the address register. So like this branch unconditional operation unconditionally transfer the program execution control to the address that is transferred from the address register. Okay. And since there is a direct connection from the address register to the program counter register, this operation can be achieved in one single clock cycle when T4 timing signal is active. Okay. In order to achieve this, the selection signal values need to be 001 and load signal of the program counter must be enabled. Okay, and at the end of the instruction execution, the sequence counter value also need to be cleared. Let us now discuss the branch and save return address operation which is performed when D5 output of the decoder is active. And this branch and save return address operation is performed in order to transfer the program execution control to the subroutine. And this operation is performed by transferring the address of the next instruction which is available in the program counter register to the memory unit whose address is pointed by the address register. Okay, and after this followed by this operation, the address register content also need to be incremented. That incremented value need to be transferred to the program counter register. Now the program counter register contains the address of the first instruction in the subroutine, and from this the instructions in the subroutine can be executed sequentially until the return statement is met. These operations are executed during the timing signal T4 and T5 as specified here. Okay, during the timing signal T4, the content is transferred from program counter to the memory unit to the location that is pointed by the address register, and also during the same timing signal address register content also incremented. And this operation is achieved when timing signal T4 is active and selection signal values are 010 and write signal of the memory unit is active and increment signal of the address register is active. Okay, and during the timing signal T5, the address of the instruction which is available in the address register is transferred to the program counter register. Here the data transfer from address register to program counter register can be achieved by setting the selection signal values as 001 and by enabling the load signal of the program counter register during the timing signal T5. Okay, and at the end of the instruction execution, the sequence counter value also cleared. Let us now discuss the branch and save return address operation with suitable illustration. Here in this figure, the content of the memory, program counter and address register are shown at a timing signal T4. Okay, here look at the memory into the location 20. The memory reference instruction that is stored right. So this memory reference instruction that performs the branch and save return address operation. When this operation is performed, the program control is transferred from the address of the next instruction, which is right now available in the program counter register, to the address that is specified in the address part of the instruction. Okay, when this instruction is executed, the program control is transferred from the address of the next instruction 21 to the location that is specified in the address part of the instruction, that is 135. Okay, into this location, this return address is stored, and then address register content is also incremented. So what is the content of the address register right now? 135. When it is incremented, it becomes 136. This incremented value is loaded into the program counter register. Okay, now this 136, the incremented value of address register is the address of the first instruction in the subroutine. Okay, from this point onwards, the instructions in the subroutine can be executed sequentially until its return statement is executed. When a return statement of the subroutine is executed, the control need to be transferred from subroutine to the main program, right? So in order to achieve this, the instruction that performs the branch and conditionally operation need to be executed. Okay, here you can see this branch and conditionally operation is performed when a return statement of the subroutine is met. Okay, in this instruction, the address part contains the indirect address. Okay, because here mode bit it contains value 1, right? So this address part contains the indirect address. Okay, so when control unit goes to this indirect address, it can find out the effective address of the instruction from where it can resume. Like this, the branch and save return address operation is performed. To the next operation, increment and skip if 0. This is performed when D6 output of the decoder is active. When this operation is performed, the memory word that is stored into the memory unit whose address is pointed by the address register is incremented, and if the incremented memory word value equal to 0, then the next instruction is skipped by incrementing the program counter value. Okay, in order to achieve this operation, the micro operations which need to be performed during T4, T5 and T6 timing signals are specified as shown here. Okay, since in this operation, increment and skip if 0, the content of the memory need to be incremented, right? Here in the memory unit, there is no signal is available for incrementing the content of the memory word. So, the memory word first need to be transferred to the data register during the timing signal T4. Okay, once it is transferred to the data register, since in the data register increment symbol is available, now by enabling the increment symbol of the data register, now the content can be incremented. After incrementing, the incremented value from the data register can be transferred back into the memory to the address pointed by the address register. If that incremented value of the data register is equivalent to 0, then the next instruction can be skipped by incrementing the program counter value by 1. Okay, here the incremented content will become 0 only when negative values are stored into the memory unit. Usually, the negative numbers are stored into the memory in 2's complement form, right? Whenever those negative numbers are repeatedly incremented, that value can become 0. Okay, so when it becomes 0, then in such case, this increment and skip if 0 operation, it skips the next instruction. Okay, and at the end of the instruction execution, the sequence counter value is cleared. Like this, the 7 memory reference instructions are executed. Students, if you find this video useful to you, kindly subscribe this channel. Thanks for watching.